Hello, imagine you have been given the task of breaking some arbitrary geometry into bricks. For simulation or for stylization, we figured out how to solve a similar problem on this channel in previous sessions, but using parametric UV coordinates, which is a form of cheating. This time we have only random geometry consisting of polygons, and the task is to brickify this geometry in kind of believable manner. So we have a couple of examples here, like some random arbitrary geometry. And we will try to brickify each of them, but we will start with the simple tube to just demonstrate the concept. So the main idea to create the basic brick pattern would be like this. We will start with the line. We have some kind of input geometry. Let's call it like an input null, just to keep track of it easier. You have this line. You need to match size this line to the input geometry, so scale to fit. That way you have line perfectly matching the y-axis. It can be different axes, but we will look at y-axis in this case. I think the concept would be the same for any other axis. So you resample this curve. Let's look at the points, something like this. Let's create grid, and this grid would be only one polygon. In this case, you can use as many as you need and as deformed as you need. For now, we will just stick with simple grid. So let's copy this onto our points. So we have kind of cutter geometry. We can increase the size of grid even more if we need. Then we will use Boolean node. First input would be our initial geometry and second input would be our cutter geometry. We will set this to surface, both of them actually. Let's disable the points. Let's create connectivity attribute. We will create it on primitives. And I have the visualizer of class attribute enabled. So to enable or disable it, you just need to go to the node info and press on the attribute name to turn it off or on. So I have my horizontal cuts and I need to get vertical cuts for this one. So let's create for each connected piece. We don't need the connectivity that was created for us. We have our own with the class attribute here. We can achieve the vertical cuts in different ways. I will show you two of them. So first one would be to use divide node and set it to remove sharp edges and get rid of any primitive that looks in negative y direction. So we will go to the normal mode in our delete node. We will set axis to -1, so negative y, and we will leave only that. But sometimes we will have situation when we have only one primitive, so we need to handle this one. We will add switch node. First input would be this. I always try to keep my setups organized, and that's why I prefer to use nulls. So let's add spare input on our switch node, and let's reference this null 9 in our case to this spare input. And let's check if number of primitives from this spare input, which means -1 in this case, is less than 2. And if this statement is true, then it will return 1. And it will select the first input in which we do nothing. In our simple case, we will always have two primitives, but sometimes it's possible to have only one, for example. Then we need to create node called Voronoi fracture. First input would be initial geometry, initial piece. And the second one would be this patch. We will need to resample this. And let's feed this into our output. And let's duplicate the connectivity node. And now, as you can see, we have controllable vertical cuts. We can control both of them. So that's neat. And this is the first way of getting the cell point for our Voronoi fracture. But we actually have some more robust ones. And unfortunately, this is one of the cases when you have to choose the right approach for particular type of geometry that you have. So let's do it like this. Let's create circle. Let's set it to ZX plane. Let's calculate some normals. For this I will use polyframe. I will set my tangents to N just to see what happened. And by default it works as I want it to work. We also can use primitive centroid in this case. I think it would be more stable. Then I will add ends node. I will enroll with new points on the U axis here. We'll increase the divisions just to have smoother shape initially. And I will increase its size a ton. So I have my normals looking inwards and I have pretty big geometry. Then I will need to create for each begin node and I will set to fetch input and I will fetch my circle geometry. Then I will create convex hull because there is a cases when we have something like a door in our geometry or something more complex, so we don't need to overcomplicate the task for us. So convex hull is working fine. In this case, I will use ray node and I will project my circle to this convex hull. And before that, of course, I need to center my circle based on the input geometry here. So I will use match size and I will match size my circle based on this null. In this case, I don't need to scale it to fit, so I will use it just like that. Now we have our thing projected and we can use the same resample and we can switch the second input of Voronoi fracture to our second solution. Let's look at the connectivity, and as you can see, it's even more stable. And this brings the second point, what if I need to alter this pattern? One interesting thing that I can do to give it more character, I can just jitter it or add some noise. So this is definitely too much in this case. So like really small amount. I can create meta import node and I can add spare input to my point jitter, fit metadata node to the spare input of my point jitter node, and I will use something like a random detail -1 iteration 0 component, and I will multiply it to some big value to have new seed each time. So this one gives us more variation on our pattern, which is really good. Also, I need to turn off the create interior surfaces in my Voronoi fracture node. So this is the first thing that we can do. Let's disable it for the time being, and we can utilize slightly different approach. But to utilize it fully, we need to make this setup a bit different. So now, because I've used the Boolean node to fracture my geometry to get my horizontal cuts, you can see when I change the iteration number, my geometry just jumps all over the place. So I cannot rely on the iteration number here. So I need to have something more stable. To get more stable order, I will utilize the packet primitives concept. So let's generate name initially. So name would be equal, let's say, piece underscore plus integer to string from class attribute. That way we have unique name for each connected piece. Let's use this name. It's complaining because I have to explicitly set that this is integer here. Then let's add pack node, pack based on the name attribute. So now we have primitive for each connected piece of geometry. Let's unpack each primitive inside. But now what we can do, we can just use sort node, and primitive sort would be based on y-axis, so by y. And instead of using the class attribute here, we will just disable this option. We will just go over each primitive. And in case of packed primitives, we have primitive and point for each connected set of geometry in this case. So let's look at the result and let's observe the behavior of our iterations. And as you can see, it's more stable. The reason why I did this that way, because I need stable control over my pattern. So I need to offset it based on the iteration number or primitive number, which are the same things in our current setup. So let's save some kind of attribute on our geometry. So let's create attribute wrangle and let's call this attribute offset, and we will divide pt num. We need to explicitly convert it to float in this case, and we will divide it by num pt minus 1. So now based on y-axis, we will have different value from 0 to 1 for this offset attribute. Let's call this attribute wrangle offset, and let's attribute remap this. So original name would be offset. Here is the trick. You have this ray geometry. Let's add attribute wrangle. Let's create float value called offset. Let's create some kind of channel called the same way, and position would be equal primitive number from 0 geometry. We will need to get position. Number of primitive would be number of the current primitive, and as a parametric coordinate we will use offset value, and of course not prim num but prim uv. I'm sorry, but now it will collapse to 1 point. Let's incorporate new curve u attribute here. We don't need to resample it anyway, just generate curve u attribute. Let's add this offset to curve u. Let's create this channel, and as you can see right now we cut this. We cut this because of the fact that value goes from 0 to 1, and we need to change it using the fraction expression. It will leave only decimal places for any number that we have here. And now as you can see visually nothing is changing, but actually now we offset the points. And we not only rotating it, we actually offset it based on the any shape that we have in our curve. So I can, for example, add mountain, and as you can see, it will follow even this complex shape. So that's nice. And this means that now we can control the offset based on some kind of attribute. And let's plug the input, I mean even packed input to this, and now we have our offset attribute on points, and here we will sample this attribute value. So let's call this thing offset external, and we will need to get point attribute from first input, and it will be offset, and point would be 0 because we have only 1 point on each iteration. And now we can either multiply this one to control the amount, for example. Let's multiply this and let's set it 1 by default. Let's disable single pass here. Let's go to the attribute remap. Now we can control the character in which we have our offset. So that was the simplest case, just a straight geometry. Let's try different geometry. For example, this igloo-like thing. And let's look at the result in the connectivity. As you can see, it did pretty good job. But actually what I would expect from this kind of structure is that entrance wouldn't be created like this. So I probably expect some kind of line or bricks following the top point of our door. So I want to make this thing follow the geometry in some way. One way of doing so would be to work on this part when we generate our line. And we will do something kind of strange. Let's create normals on the line. I think after a sample would be fine. Let's enable this and let's set normals to be positive x. And let's offset this line by negative x. For example, minus 10 in this case. Let's copy and transform this geometry. Let's copy the total number and let's paste it into y rotate. and divide 360 by the total number of copies. Let's increase its amount, and now we have some kind of circle with normals that looking inwards. For this thing we need to have different resample, and let's resample this to something really small, kind of like this, and let's project this onto our initial geometry. So first input of ray would be the lines, and second would be the input geometry. Now we have something really weird, but that's okay. That's actually what we need. Let's generate heat prim attribute and let's look at its values. So sometimes heat prim is -1, and this is the points that we don't need. So let's use blast node, and we will blast points based on the heat prim attribute that equal -1. That way we got rid of any weird and unnecessary points. And before we copy this, we need to store the rest position, and after we blast it, or even before, it actually doesn't matter, we will set its position back. So position would be equal rest attribute. Just in case, we will set it to be vector. Now we have all points in one place. Actually, we will do it after the blast because we need additional operation here. We need face node, and we will remove inline points. Now we have much less points. Let's increase this distance to something sensible to us. Let's add node, delete geometry but keep the points. We will use fuse node. We will increase the snap distance, and we will output minimum value of this position. We can try to go without add node, but now we have too many primitives. So the idea, when we resampled it, we have left only points with drastic deformation based on the phased angle. So now we have only these points. We can fuse it. Then we can add sort node, sort the point based on y-axis. Let's add additional add node, and we will connect by group, and it will work right away because we have pretty simple case. I need to increase the snap distance to get rid of these small segments, and then we will add additional resample, and this resample will be based on the polygon edge. So we will still keep the points, like a pivot points, but also we will resample something in between for each segment. And let's replace second input of our copied to point node to newly generated curve. And let's see what we have right now. Let's disable normals, and you can see that this line is more believable. It's actually taking into account the entrance. Let's try to change size of input geometry, and I think resample here could be less. And as you can see, even I change my resample to something really big, it still follows this entrance line. So let's increase the size, and as you can see, we still have our bricks following the entrance almost perfectly, which is really cool. We have some weird things on the top, but we will handle this in next iteration. To get more speed with this particular setup, we can compile this thing. So we will add compiled block. We need to add compiled begin. Here we will multi-thread when compiled, and now we will have faster execution of our cuts, which is really nice. So this example is working kinda good. Let's move to other one. So I will duplicate this setup. The third example requires some additional preparation from us. We need to split parts that we want to be brickified from the parts that we want to keep as it was before. For example, clearly this upper part, some of the slopes here, and we will separate it based on the normals and based on the y direction of normals. So we will create attribute triangle, we will set it to primitives, we will create mask attribute, and it would be equal normal y. Let's visualize this one, and we have some parts highlighted. Let's use node called vertex split, which will split geometry based on some attribute, and now we will use mask attribute, and let's again use connectivity node to observe the way our geometry got splitted, we will disable the visualization of mask attribute and we will enable the visualization of connectivity class attribute. And as you can see, it splits it in some way, but we need to increase the tolerance to get more sensible shapes. So for example, something like this. And now we can split geometry, one of which would be the roof and the support geometry. To do so, we will add additional attribute wrangle and we will use primitives. Let's disable the visualization of class attribute and enable mask, and we will rewrite this attribute again. So it would be equal, mask would be equal dot product from primitive normal and y-axis. So set 0, 1, 0. And we will use absolute function to have only positive values. And also we will use tramp. Let's call it dot. Let's create this thing. Let's make it more contrasty. And we will split our geometry based on newly generated mask attribute. And it would be less than 0, 1. Just in case we will set the group type to primitives. And that way we have only walls geometry. Let's look at what we have right away. Let's enable the class attribute. And we don't need this one on the points. And now we have our geometry splitted, but we have some weird issue on these parts. Let's fix that. And we need to generate this cutter geometry in a different way. Let's get rid of the second way, just temporarily. We can implement it later if needed. And what I need to do, instead of generating all this geometry outside, I will generate this line for each piece. I can just generate one line without any projection, but because of we already have this kind of nice setup, we can try to utilize this one. So we will create for each connected piece, plug our geometry here, and here as a second input of match size, we will use each piece. And that way we have generated a bunch of lines instead of one. Let's look at the result. And now it's better. Now we can control the segment length and we can append our roof at the end from the second output of the split node. And we can control what exactly we define as a roof using this ramp. And based on the angle of normals, we can select different parts. We have really fast setup. And additional neat thing here. We have some unconnected points in this geometry. For example, here is the result of errors from Boolean node. But because of the fact that we packed this, pack actually warns us that source geometry contains unconnected points and packed fragment primitives currently only support primitive contents, which is exactly what we need. We just get rid of any unnecessary unconnected points. So this setup is pretty nice. And you can add all sorts of randomization for each iteration. Here you can alter the resample count, for example. You can try to add all sorts of variation, noise, point jitter. So we add more of an interesting character here. Of course, not too much. What we can do additionally, when we copy our grid here, we can add attribute randomize. It would be, for example, n. Let's use inside sphere. Let's change the cone angle to something really small to have a slight variation, something like this. So really small. And that way we have also interesting horizontal cuts. Of course, not too much, just a touch. We don't need uncontrollable geometry. So that's the third example. And finally, let's look at example number 4. Let's look at what it will give us out of the box. At first glance, it seems fine, but actually, if we will look closer, we will spot this slight unwanted cuts, and it's dangerous because it's unnoticed. Why we have this is because of the fact that we try to project curves on all our geometry at once. And also we cut all this geometry at once. So cuts from this part, propagate into the next part, and the same otherwise. Let's fix that. First thing that I actually don't like here is the fact that when we generate our curves here, we have ray node inside of our loop referenced whole geometry. And this is definitely not what we want. We need to reference some concrete piece. So let's change this behavior. Right now it's better, definitely. Let's look at the result with this fix. It's kind of more stable, but again, we have some kind of weird issues. And again, we generated the points in the loop, but also we need to cut each primitive in the loop also. So instead of using input as a first input of our boolean, let's actually use for each begin, and let's make this loop go in here. And that way, even with this complex geometry, of course quote-unquote complex geometry, we have our cuts more predictable, and this part is actually not intersecting with this one. So that's definitely better. We can test it a bit further and, for example, add poly extrude on one of the polygons here. And as you can see, it's really trying its best to adapt to the shape of geometry, trying to preserve the features, which is not always perfect. You probably want to fine-tune your views, but as you can see, it's kind of believable. Generally, this solution not perfect, and I'm on purpose have chosen this pretty weird geometry. In real life, I hope you will get something better. And we, for example, can duplicate this poly extrude node, and we can select something else. For example, these two polygons on the right side. So yeah, let's check the output. Yeah, it's trying its best, definitely. So this is like really nasty complex chunk here, but I'm glad that we have kind of sensible distribution. Let's actually test this one with, for example, pig head, some completely random geometry. And we see this weird thing here because of the fact that we have this vertex split and we never appended the roof geometry back. But from my point of view, this particular setup is not suited well with the pig head. We can, of course, decide amount of what we consider as a roof, but previous setup would work much better with this particular case. So let's just test this. And let's go here. This is actually pretty cool because it's trying to do its best in terms of preserving features of this geometry. And we, of course, can just ignore that and, for example, generate just a straight line instead of all this stuff here. So we can just switch it. And now we have even polygons, which is also can be desirable. But yeah, as you can see, we have pretty good foundation for robust system that will give us interesting results. We can, for example, change the target size on each connected piece, and we can add all sorts of cool variation to it. Again, attribute randomize in conjunction with point jitter or something like this would work really nice.